I'm here with Dr. Romano to do a video on phase diagram.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products and the author of the DAT Destroyer book. I want to go over what's known as a phase diagram. These are very important questions for the DAT exam. A phase diagram in general chemistry is often used to determine is a compound a solid, liquid, or gas at a given temperature or pressure. So come on over and let's have a look at how we go about doing this. Here's a phase diagram that I made for you. And as you can see here, we have the solid phase in this area. This area is liquid and this area is gas. So hypothetically, if I said to you we were at 195 Kelvin and 73 atmospheres of pressure, you would go to the 195 Kelvin, you would go all the way up to 73, and you can see you would be in the solid phase. But let's say I said to you, I'm at 73 atmospheres and say 280 Kelvin. Well, 280 Kelvin would put me here, and then you would go up to the 73, and that would put me in the liquid phase. So you should be able to look at the diagram and see where you are. So we have the solid, liquid, gas. When you're on a line, that's an equilibrium point. So that would mean that you're between the solid and the liquid at this point. So that equilibrium point is called the melting point. So that's a melting point. If you go to here, you're now at the boundary of liquid gas. This is a boiling point. And if you were here, this is the boundary between the solid and the gas. That would be the sublimation point. Of course, the reverse would also be true. That here, instead of saying boiling point, instead of saying melting point, you can also say the freezing point if you were going in the opposite direction. And then instead of saying boiling point, if you were going in the opposite direction, you can say condensation point, and the deposition point would be the opposite of the sublimation point. And then finally, you should know when the solid, liquid, and gas all coexist together in equilibrium, that's called the triple point. And then this point, highest up here where you can't go any higher, this is called the critical point. If you go above the critical point, then we get what is known as a supercritical fluid. Now, what can you learn about the density by looking at this diagram? Now, the way you do that is you look at this line right here. I'll put it in red. This is the solid liquid line. If that line is skewed to the right, as you can see, and it is skewed a little bit to the right, that means the density of the solid phase is greater than the density of the liquid phase. And that's the norm. The solid is usually denser than the liquid. But if the line was skewed to the left, if the line was skewed more to the left, so in other words, on our graph, you had this and the line is more to the left, then that would mean the density of the liquid phase is greater than the density of the solid phase. And that's kind of rare. An example where you would see the liquid is more dense would be like H2O. All right, let's get back. So what can we learn about the density? What we can learn about the density is the solid phase is more dense than the liquid phase. This happens to be the graph of carbon dioxide, which brings me to part C. Does the solid carbon dioxide float or sink in liquid carbon dioxide? Well, we just see from the graph that the solid is more dense. So if the solid is more dense, then it will sink. Okay, we got a couple of really good problems on this in the Destroyer book. I hope this clears up on how to read a phase diagram. Okay, good day to you. I'll see you in study group. Bye-bye.